relative to owning Netflix, which one would be safer option? If I told you that cash flows are exactly the same, which one would you buy, Coke or Netflix? Which one is the safer bet? Coke, because it's a very well established company. I mean, they exist in more countries than there are actually countries. It's everywhere. Netflix may be here today, may not be here tomorrow. And they've been doing a lot better than people gave them credit for, but that doesn't mean it's not riskier than Coke. So proper discount rates for Netflix should be higher than discount rates for Coke. We're going to spend chapter 11 pretty much towards the end of the semester to figure out what that rate should be. But for now, we're going to kind of assume a number and go with that. So if I have a 1 year investment horizon and I'm going to assume that I know exactly at what price I could sell it, I know my cash flows, I'm going to get D1 as dividends. Plus, when I sell the stock, I'm going to get P1. Of course, I'm going to discount that by 1 year, right? The trouble with this approach is I don't know what that P1 is. It's like a chicken and egg. I want to calculate the value, assuming the future price, but I don't know that future price. So let's iterate on this process. Come on. Now assume a 2 year investment horizon. You will get D1 in 1 year, D2, which is the second year dividends, in 2 years, and sell this stock at P2 in 2 years. And I can get another approximation for this value. My first year cash flow is D1. Of course, I discount that at 1 plus R. But second year, I'm going to get D2 plus P2. It's a little bit better, but I still have P2 in there. So let's iterate this one more year. You will get D1, D2, D3 plus P3. This is in 3 years. This time I'm going to separate them. That doesn't solve the problem. So I'm going to go ahead and iterate this ad infinitum. dot, dot, dot. That means I'm going to keep adding these terms with no end. This kind of a technical condition provided in the future, present value of the price you're going to get gets closer to zero. That's just a technical condition. I can write this in concise form. This is called a summation notation. It simply says for each year, calculate the present value of expected dividends for that year and add those up. It is a concise way of writing this one. Mathematicians are, good for concise stuff. And basically it says, you can think of that as present value of expected dividends in year T, paid in year T. Hence our view that uh, value of a stock is equal to the present value of all expected future dividends. Theoretically, it's neat. I can even write it up in a single notation, no problem. But there are problems of implementation. This depends upon two kinds of inputs. One is the proper discount rate, which is a separate issue, which we're going to tackle later on. Suppose you know the proper discount rate. The second one is, I need a dollar sign here. The second one is expected value of all future dividends. And there lies the problem. If I ask the executives of Coke, who knows everything about Coke relative to us, that what is your expected dividend in 25 years, they're going to kick you out of the room. They're going to say, I have no idea. I mean, they can give you a number, but their confidence in that number is going to be lower and lower. And that's also kind of the law of nature. Anybody heard here second law of thermodynamics? It's neatly summarized as entropy always increases. Entropy is chaos, disorder. As time passes, disorder in the universe always increases. It's one of the immutable laws of the nature, except in quantum mechanical words. But uh, outside of nucleus of an atom, entropy always increases. Okay, this is a fancy way of saying your confidence in a forecast 1 year down the line is a lot higher than your confidence in a forecast you're going to make 20 years from now. To operate, to make this model operational, we're going to have to make some simplifying assumptions. This is kind of how science also works. Uh, when Newton came up with his laws of gravity or laws of motion, he knew that it wasn't the proper way of doing it, but it was okay for the purposes he had in hand. You could use Newton's second law of motion and predict exactly, not exactly, but very approximately where Neptune is going to be 25 years from now. As long as you have a good estimate of mass of Neptune, mass of uh, Jupiter and Saturn, and mass of Sun, it's not that difficult to do. I mean, you may not know the mathematics for it, but there are ways to solve those differential equations. No problem. The trouble arises if you want to do the same thing for the Mercury orbit of Mercury, then suddenly Newton's laws of motion is not appropriate. And in fact, there were errors. People could not explain it until a very little known Swiss patent officer named Albert Einstein came along. Newton had no idea why gravity was working the way it was working. Einstein said, I know how.